So under this fluctuating agents, electrolytes, I have already told. In case of electrolytes, the absence of cake formulation is well correlated with the maximum sedimentation volume. The above example illustrated the principle of achieving controlled flocculation of positively charged solids. The same principle can also be demonstrated by taking an example of a positively charged flocculating agent such as aluminum chloride. So positively charged flocculating agents example should be what? Aluminum chloride. And negatively charged suspended particles such as sulfaramaz, sulfamerazine. Sorry, sulfamerazine. In this case, the particles possess negative charge initially and have a negative zeta potential. On addition of trivalent aluminum ions, the zeta potential will gradually increase and become zero due to surface absorption. Finally, the dispersed particles assume positive charge on further addition of aluminum chloride. Most dispersed particles may possess charge depending upon the pH of the system. In such cases, a guiding principle is to reduce the charge to zero by adjusting the pH of the system by using the buffers and pH adjusting agents. Okay, so since zeta potential of a suspension is well correlated with the cake formation and state of flocculation, it has become quality control tool for the preparation of flocculating suspension. So these flocculating agents have a big these flocculating agents are too much important things or too much important parameter for formulation of pharmaceutical suspensions, because in case of pharmaceutical suspensions, the flocculated suspension is mainly used, and for making the or formulating the flocculated suspension, flocculating agents must be added to the suspension. So electrolytes is also used as flocculated suspensions. Surfactants. The surfactants also used as an flocculating suspension. Surfactants improve the dispersion by reducing the interfacial tension. They also act as a weighting and deflocculating agents. Remember, surfactants also acts as weighting and deflocculating agents. Hence, the concentration of surfactants is critical in achieving the flocculation. As a surfactant is used for flocculating agents and it also acts weighting agents and deflocculating agents, so concentration of the surfactant is too much important. It is critical in achieving flocculation. In case of ionic surfactants, the head portion adsorb on the solid surfaces and the tail project outwards and form bridges between the particles. Surfactants have two portions. One is head part and another is tail part. So in case of ionic surfactants, the head portion adsorb on the solid surfaces and tails projects outward and form bridges between the particles. Such an arrangements bring about flocculation and prevents the precipitation of solids. For examples, sodium lauryl sulfate (SLS) and sodium dioctyl sulfosuccinate. Non-ionic surfactants such as twin also assume partial negative charge in the aqueous dispersion and forms a network-like structure between the particles. Okay, so for ionic surfactants, the examples were what? SLS, sodium lauryl sulfate, and sodium dioctyl sulfosuccinate. For non-ionic surfactant, what should be the examples? Twin, twin 80, twin 40. That means polysorbate 80. That is that is also called twin 80. Twins also assume partial negative charge in aqueous dispersions and form network-like structure between particles. Polymer. These polymers act as flocculating agents because a part of polymer chain get adsorbed on the particle surface, with the remaining portion projecting out into the dispersion medium. This behavior is shown in case of xanthan gum. Anionic heteropolysaccharide has it has increased the sedimentation volume and sulfaguanidine suspension, presumably through the bridging phenomenon. The protective collateral action of hydrophilic polymers can be made use of in preparing suspensions of improved characteristics. They form a mechanical barrier or sheath around the particles and induce flocculation. This mechanism is more useful to improve the appearance of flocculating or flocculated suspensions. For example, in acidic solution, sodium sulfathiazole precipitates carrying the negative charge during the precipitation process. If a positively charged colloid such as the gelatin is also present, then gelatin forms a coat around the negatively charged particle. Okay, now these dispersed particles assume a slightly positive charge. These particles are less prone to cake formation. So everyone understand what are the mechanism of polymers? For example, in acidic solution, sodium sulfathiazole precipitates carrying the negative charge during the precipitation process. If a positively charged colloid such as gelatin is also present, then gelatin forms a coat around the negatively charged particle. Now dispersed particles assume a slightly positive charge. These particles are less prone to cake formulation. Clear? So API done, wetting agents done, flocculating agents. There are several type of flocculating agents can be used, like electrolytes can be used, KCl, NaCl solution, surfactants can be used. Uh, they are classified like non-ionic surfactants and ionic surfactants. Ionic surfactants examples I have already told, that is sodium lauryl sulfate and dioctyl sulfosuccinate, and non-ionic surfactant twin 80 or polysorbate 80. So surfactants, electrolytes done, polymers like xanthan gums, which increase the sedimentation volume. So flocculating agents done, thickener or thickening agents done. I have also told the classifications of thickening agents or the thickeners, like polysaccharides, inorganic agents, and synthetic compounds. Under polysaccharides, natural polysaccharides are there, semi-synthetic polysaccharides are there, and under the inorganic agents, clay is there and aluminum hydroxide is there. So thickening agents or thickeners done. Now the buffers and pH adjusting agents, osmotic agents. These are added to adjust the osmotic pressure comparable to biological fluids. Like it is used properly, like the ophthalmic preparation for adjusting the osmotic pressure, for adjusting the isotonicity. Isotonic agents are also used in case for ophthalmic preparation. Then the coloring agents and flavoring agents, and comes to this point, the preservatives prevent the microbial growth, and the external liquid vehicle. They are added to construct structural or structural modification or construct structure to the final suspension.